and this is example 2. Which one's in and which one's on?
That one's on.
Okay, the forces are acting on the same plane. And that is, the forces are acting in the same plane. So which ones are coplanar? The in or the on? Look at the definition.
F2 and F4 are in. F1
So the one on the board is coplanar.
The one on the board is coplanar. So when you draw on your paper, they're all coplanar because they're on the same plane, unless you're drawing in 3D. Right? So assuming that that is a 2D drawing, all those forces are acting in the same plane. That is coplanar. This is not coplanar. So you have to remember it's in, not on. Okay?
So F1.
Question?
Yeah, F1 and F3 are coplanar, and F2 and F4 are coplanar?
No, all of them, aren't they all, actually, the reason I got confused is that picture shows in and on,
Yeah.
right?
On the beam. but
So
it's-
that's why it's a very bad example, and that's why I was confused for years, I think like 10 years until somebody said, Joanna, are you sure about that? You know, every once in a while there's something that I blow, and for years, and I didn't even know. So that example is poor. It's what's better is that we need to know that the definition. So coplanar forces are forces acting in the same plane. Those 4 forces, are they acting in the same plane? Yes, so they're coplanar, but they're also acting on the same plane. So let's go to this one.
Wait, I'm sorry.
Wait, let's go to this next one and then come back.
Wait.
So, wait, look at these. Are these guys coplanar? Are these guys coplanar? Yes or no?
No.
Yes. Put your hand up. Yes. No.
No.
Okay, what's the definition of coplanar? They're acting in the same plane. Are these guys acting in the same plane?
No.
No. They're on the same plane, but they're not in the same plane.
Come on.
You can't say that some are, because they don't give you any dimensions. You have no idea if this is lined up with this or this, right? Okay, so does everybody understand? This is, all these forces are acting on the same plane. Are they coplanar? No. Are these coplanar? Yes. Are these coplanar?
Yeah.
Yes. Are these coplanar? Yes. So the definition of coplanar, it's very important that you remember that it's in, because this example is terrible. Santiago.
John, so what would you change in your book example to make it coplanar? When you're holding all the forces on the book.
Yeah, okay, so if I wanted, what, say it again?
When you're holding.
Oh, in order to make them?
Yeah.
Okay, so in order to make these all coplanar, I would have to put them all center of mass on the edge. Because now they're all static. This is statics class. I gotta see how good I am. These are all acting on the same plane now, the vertical plane. Okay.
Actually, wasn't the water.
Oh, I put the water in.
So coplanar, they all have to be on the same.
They have to be on the same, well, I don't
On
want
the
to say
same
same
portion
axis.
of a plane?
Same plane, like, they have to be lying. They have to be lying on the same plane.
So it'd be a vertical.
Well,
Opposed to horizontal.
well, let's use my fingernails as arrows. So these guys are all acting in the same plane, right? If I made, you guys, if I made the plane vertical, horizontal, if it was a horizontal plane, how can I make, right now, is my force coplanar with the ground?
No.
No, but if I lie down, am I? Yes, because if I'm, no, because the force is still going down. force isn't going horizontal, you're right. But if we had a bunch of forces,
If
if
I was
we had a bunch of
driving-
cars, I don't know, it doesn't make
Okay,
sense.
if you like this, if you have a slab with a floor, when you're standing on it, it's not, but if you were to come around and push the slab.
Then it would be, great.
Because you're
Did you hear-
pushing it along the axis that that plane lies on. So if your plane is on the x-axis and you're pushing down on it in the y-axis, it's not, but if you would have to push it in the axis that the plane is.
Great, that's a great way to explain it. So the force has to be pushing along the plane. Lonnie?
Yeah, I'm trying to figure that out too. So it can be like any plane, if there's any way you can switch it to be a 2D thing and everything is
That's right.
acting on that 2D.
Good, that's another way, good way of explaining it. We're looking at, it has to be two-dimensional, can't be 3D,
Even if.
right? We're spending more time on it than we need to, really.
But can I ask
Yeah.
though, in that coplanar example, that plane is on the x-axis. So F1 and F3 are not coplanar, but F2 and F4 can be because their y components are technically pushing in the.
All right, let's say that again. So right now,
I don't like
these,
that example.
yeah, let's just not use this example.
It's not there.
Get a better one.
It's in the workshop.
Yeah, well,
Epsilon and pi.
we can cross it off. Okay, can I move on? So did we go to this one yet? So, look close. Are each one of these forces labeled a different variable?
Yes.
Yes.
Yes, so is it concentrated or distributed? Concentrated, these are concentrated, and these are point loads. They're not distributed. Are they coplanar? No, actually, you said how about this? If the forces are perpendicular to the plane, they're not coplanar. If the forces are perpendicular to the plane, they're not coplanar. It's only if the forces are on the plane, lying on the plane. That, it seems like some people just got it. Sam?
Can you have a concentrated force that's not a point load?
No, they're synonymous.
Okay.
Those two words are synonymous. Concentrated and point, you could say they're synonymous. Okay, let's take a look at this last one here. And I do want you to do this. Because you're never going to see a distributed load without that horizontal line on top. So this is a uniformly distributed load, so I would represent it as a force divided by what? Not area, length. And usually they use the little L. Because it's not 3D, right? It's only a strip. It's two-dimensional. So are these concentrated loads? No. Are they point loads? No.
So you said it's not 3D?
Well, it's a concrete slab. It's got to be three-dimensional, right? But when we analyze it only as a 2D.
Do we always do that with
Yes.
force of it?
A lot of times. You'll see as we go along.
Do we ever take superposition into consideration?
What's superposition, like one on top of the other?
Like,
I don't know what superposition
you have all
is.
these forces, but you look at the general direction of all the forces together.
Like a resultant.
Yeah.
Yeah, we're always about halfway through the semester, we're going to take a very, very complicated problem and simplify it into one force. Okay, so that's one topic of Chelsea.
So if we're taking most of the things that we do in this class and making them two-dimensional, then most of them are going to be coplanar forces?
On the ones we make 2D, but so far we have done 2D and 3D problems, right? This is made into a 2D problem because the same loading in the front is the same loading as the back. It's the same exact thing. Just like the car, the loading that we see is the same as the loading in the back. It's symmetric loading, so we can simplify it to a 2D. This one we can't simplify to 2D. It's a 3D problem. Okay. so let's get, we're moving into the next topic then, we're going to moments now. Who's lefty in here? Just Aaron and me?
Wait.
Well, we have an advantage, oh, and Jack, did you have your hand up? We three have an advantage. We can write and use the right-hand rule at the same time. All you righties, you gotta write and then do the right-hand rule, and then you gotta write and then do the right-hand rule.
I can use my and then just flip it over.
Yeah. You must be really smart then. Okay, so we're practicing doing moments, but before that, we're gonna look at some videos again.